Researchers are looking for new methods of keeping expenses down while improving overall efficiency, and the relatively new market of unmanned aerial vehicles, UAVs, or drones, is no exception. Waugh is a professor of mechanical, industrial and aerospace engineering at the Gina Cody School of Engineering and Computer Science. The experimental technology replaces the commonly used hinged wing flap with one that is attached to the main wing body but can bend up to 20 degrees. Our paper shows that a UAV using this kind of wing can support a good amount of load for small or medium-sized vehicles, says Waugh, director of the Concordia Center for Composites. Using material reactions 4D printing is similar to 3D printing except that it changes materials from location to location. The separate material is used because it is reactive to a particular stimulus, water, cold or heat, for instance. Composite 4D printing is more complex. Rather than using a soft, dough-like substance commonly used by 3D and 4D printers, it relies on a sinewy combination of long, fine filaments held in place by a resin. Each filament is only 10 microns thick, about 1/10 the diameter of a human hair. The 4D composite printer unrolls its filament resin mixture in ultra-thin layers at 90-degree angles from each other. The layers are then compacted together and cured in an oven at 180 C, and then cooled down to 0 C, creating an object that is stiff but not brittle. As the authors explain in their paper, this allows them to create a section of material with a uniform curvature that is sandwiched in between the wing flap's upper and lower surfaces. It is flexible and strong enough to support the 20-degree deformation the wing requires for flight maneuverability. The idea is to have a wing that can change its shape easily during flight, which would be a great benefit as compared to fixed-wing aircraft, Waugh explains. He believes the composite 4D technology has great potential for all manner of applications. Its product's transportability, he says, is a major draw. Because it is flat, it is easy to package to send to remote areas, from Canada's far north to outer space. Video of Suong Waugh discussing 4D printing of composites. u2.be/j7k-zjg0qpay make a difference. Sponsored opportunity story source. Materials provided by Concordia University. Original written by Patrick Lichteny. Note: content may be edited for style and length. Journal reference: Suong Waugh, Marjan Abdali, Anik Jasmine, Daniel Radeshi, Victor Prats, Hadi 4, Bakr Kobesi. Development of a new flexible wing concept for unmanned aerial vehicle using corrugated core made by 4D printing of composites. Composite Structures, 2022, 290–115,444 doi, 10. 1016, J. Comstruct. 2022, 115,444 Cite this page. Concordia University. 4D composite printing can improve the wings of drones. Science Daily, the 10th of May 2022. Concordia University. 2022, May 10th. 4D composite printing can improve the wings of drones. https://ift. BVNQRZ3. Accessed May 10, 2022. Thanks for watching. Please subscribe my channel for more videos.